And that's how do we actually decide what the threshold should be, right? The goal isn't the rule itself in this example, but how we determine the threshold X. Now this is where things start to get interesting, okay? So instead of asking what should the threshold be, we ask what does normal behavior actually look like by industry standards, that a percentile around the 95th or the 97th percentile is usually a good starting point. Throughout the webinar, you're going to see quite a lot of graphs and quite a lot of visuals. And that's done intentionally just because we think that visualizing key concepts like this is much more easier to understand and much more easier to implement in practice. Great. Well, welcome everyone. Thanks a lot for joining. I can see quite a few participants and some familiar names actually. So it's great to see that. My name is Konstantinos. I'm a product owner here at ComplyTech. I know we've got a mix of regulated institutions as well on the call. So this should be quite relevant across the board. So the topic today is about something that actually sounds quite simple, but in practice is usually quite difficult and painful to implement. How do we move from the guesswork to a structured and defensible approach? And that's usually a common pain point that we see a lot of the times with our clients. And that's exactly what we wanted to walk through today. The webinar is intended to give everyone a core structure, if you want, and a core methodology to follow and implement in your own program. But more importantly, from my perspective, is to just give you an understanding of how you can use proven methodologies that are used industry-wide in a scientific way to set your threshold. If we manage to achieve that, that's my goal for today. And hopefully this will give you a very good overview. Just jumping to our agenda now, the key inspiration, if you want, is to move away from the typical webinars in the space, which often feel quite abstract and theoretical in nature. And the point of today's webinar is to just give you a more practical kind of approach and something that you can take and implement directly into your program. A good place to start, I guess, is with the problems, which I'm sure most of you would recognize. We'll then walk through the practical example that we have, a structured approach that you can use to deploy in a live environment. And finally, probably the more interesting bit is how you can continue to improve once you have real data and alerts from your transaction monitoring program. Just before I jump onto the next slide, just a question for everyone, a poll will come up. It would be good to get a sense of what is the biggest challenge that you face with transaction monitoring today. So I'll give everybody a few seconds to vote. Okay, let's have a look. The majority actually has voted for all of the above. So it's quite good to see that actually there's quite a bit of value in this. And then the second highest answer was high false positives. And this is actually exactly the pain point that we were expecting. But it's interesting to see that all the kind of reasons that we have labeled out, all the answers, receive kind of even attention. And it's completely understandable from all perspectives, not just from false positives. I guess we want a more structured methodology and a way that we can explain the thresholds that we set. So really, really good to understand the perspectives. Thanks, everyone. Before we jump into the actual methodology, it's just good to just ground in reality for a second. Regulators are quite clear when it comes to transaction monitoring that systems need to be calibrated and effective. Okay, that is very clear across all really regulators within the EU and abroad as well. The interesting aspect of this is that they don't really tell institutions how they can do that. And that's where the most institutions we find struggle, is turning that expectation into something that is quite practical. This key pain points on this slide will probably look familiar in most environments, where thresholds are either set manually, they're either inherited from legacy systems or existing processes, or are adjusted as a reaction to alert spikes over time, which is not really the right way to approach this, right? We want to have a predictive, structured methodology to set our thresholds. And this leads to the problems that everybody has already outlined in their answers. the alert volume is quite high, really, and we have quite a big percentage, often within 95 to 98% of false positives. The regulatory stance, of course, is quite unclear and not easy to justify. And then in terms of having a structured methodology and testing cycles, which are not very reactive, but are rather predictive in nature. So by applying a methodology like the one we're going to walk through today, it's quite easy to see the benefits from that. A key aspect of any kind of analysis within the space, but more importantly, when we use data like the one we're going to cover today, is the quality of the data that's going to be used. Because honestly, if the data isn't right, everything that follows is just noise, right? So you want to start from a solid basis of accurate data. And what we mean by accurate data is data that is complete, is consistent, and ideally monitors the full behavior cycle. So from point one, as you can see, the recommendation is to usually have data collected from the past 6 to 12 months. And the reason for that is because that avoids any seasonality in the data. So different spending patterns that might be observed over specific months are usually kind of evened out if you have a data set of about 12 months worth of data. And then in terms of the data structure itself, we want to have the key fields available to us, which all of the institutions would have available, which is the transaction ID, the customer ID, some kind of timestamp of a transaction, and the base amount. Direction, of course, whether the transaction is incoming or outgoing. And on top of that, it's very critical that we normalize this data. So for example, if you can see the example we have on the right-hand side, different date formats need to be standardized to a single date format. If you have different currencies within a transaction data set, of course, you need to use a base currency. So all of these activities and all of these steps are taken with one common goal, and that is to standardize the data and have good data quality before we even begin any kind of analysis. It's important to note here that after our webinar, we'll provide you with the material that one follows the exact methodology and helps you use your own data to apply the methodology that we covered today. These are kind of technical in nature material that you would be able to input your own data and utilize for your own needs. So this kind of material would be made available to you after the webinar, just because we found that there's a great need in the industry for something like this. And we want to help our clients and our partners in this. Just back to our slide here, just as an endpoint, another question for you of what you do today to achieve well-calibrated and efficient thresholds, if you do any kind of work around that. So again, interesting, but expected at the same time. And again, this is exactly what we see. The top answer is manually or based on experience. And even though experience does help, it of course has some value in setting thresholds, it's not really the right way to go about doing something like this, because if a regulator comes and asks for rationale around your setting of thresholds, answering based on experience will really not hold up very well. So yes, experience is very helpful in determining and adjusting thresholds calculated by methodologies such as the ones that we're going to see today, but it shouldn't be your main point of reference. Other answers, such as based on historical settings, periodic tuning, and structured data-driven approaches, happy to see those are being applied, and hopefully with the methodology today, that's going to really enhance those steps as well. So thanks for the answers. To make this a bit more tangible, we're going to walk through a simple example. Imagine a rule which is basically detecting high value outgoing transactions, okay? A very simple rule. And you want to determine what the threshold of such a rule would be, or the threshold X in this example. So nothing fancy, no time parameters in this rule, as you can see, etc. But I think it's a perfect illustration of the point we're trying to raise. And that's how do we actually decide what the threshold should be, right? The goal isn't the rule itself in this example, but how we determine the threshold X. Just as an example, we're showing a preview of a data set and how one would look like using quite common fields, such as we mentioned before, the transaction ID, the customer ID, etc. And this covers the point of data quality that we mentioned. Again, clean data, validated data, and summarized data, like we see here, is really important before we begin any type of analysis. And this step is just really a sanity check that we're working with something reliable, or are we building an analysis on top of bad data? At this stage, we're not touching any thresholds. This is just a cleaning step before we begin any type of analysis. And as we can see from the example, a very low percentage of rows have been dropped, 0.68%, which indicates that after the cleansing activity, our data set is of good quality and can be used to move forward with the analysis. Okay, now this is where things start to get interesting. Okay, so instead of asking what should the threshold be, we ask what does normal behavior actually look like? And to determine that, the first step is to utilize percentiles. Now, the concept of percentiles might sound a bit intimidating at first, but it's quite simple in nature, really. So just a very simple example. Imagine if you took your customer base, lined your customers up from lowest to highest activity, and then chose the customers that fall in 95th percentile, for example. That would indicate customers who have transacted more than 95% of your customer base, right? And this concept is used as a first step to kind of gauge initial thresholds or appropriate initial thresholds for our activities next on. So as you can see from the distribution graph on the left-hand side, choosing a percentile around the 75th margin would usually capture normal behavior as well. So it's recommended by industry standards that a percentile around the 95th or the 97th percentile is usually a good starting point, right? Because that usually indicates abnormal behavior towards the tail end of the graph, as we can see from the graph on the right-hand side. What's key here is that throughout the webinar, you're going to see quite a lot of graphs and quite a lot of visuals. And that's done intentionally, just because we think that visualizing key concepts like this is much more easier to understand and much more easier to implement in practice. Moving on from the actual kind of theory of percentiles, and if we start really labeling out our percentiles, you can see we've calculated example thresholds or example percentiles rather for our population that we're going to use for this example. So we started off from P90 and we went all the way to P99.9, and the indicative amount spent per percentile are shown on the screen, right? So in terms of what the actual distribution of your customer base would look like, it will look more something like this slide right here. Okay, the behavior that's abnormal is going to usually appear on the tail end of your graph if you're going to visualize this. And most transactions in terms of normal behavior would sit between the percentiles from 0 to all the way to P90. And then you've got the tail end, as we mentioned, which would usually indicate your outliers. And this is the key here. We're not trying to flag the volume, not for this step. We're just trying to isolate abnormal behavior. And that's really the key when we're working with percentiles. So if we move away from the visual and more into the numbers side of things, instead of picking a threshold and hoping for the best, we simulate. And we do this using the historical data set that we worked on from step one. And we simulate the percentiles to reach monthly alert volumes, as we can see on the screen. So for example, using the historical data, if we set the threshold at P95, would get 8,400 alerts. If we set it to P97, naturally the number of alerts drops to 5,100, etc. So once we simulate the different percentiles, we ask the question, now which percentile do I choose from this? We are now no longer reacting. We're actually predicting the impact before we do anything else. And you would notice that as we go down the percentile table and as the percentiles increase themselves, the volume of alerts naturally drops, right? But what's more interesting and what's a common trend that you would find most of the time is the concept of diminishing returns. And what that means is that even though the volume of alerts drops, the impact or the percentage change from the previous percentile diminishes. So as you can see, going from P95 to P97 has a 40% drop, but going from P97 to P98 has a 35% drop. And that's indicative on the operational impact increasing the percentile would have based on the number and volume of alerts produced. So we need to find the ideal balance between the operational impact that a certain percentile we have in regards to the risk coverage that it would offer. Because naturally, as we move down from P90 all the way to P99.9, the risk coverage drops because we are monitoring a smaller, part of the population. So we need to find the right balance for this. If we assume that we start from an initial point of setting an industry standard P97 to begin with, we now need a few steps to validate this threshold and make sure this is an accurate threshold, right? And there's a few steps that we can take to validate this and make sure it's a proper pre-deployment threshold that we can set for our rules. Before I jump to the validation steps for each of these percentiles, when adjusting your threshold, what is your primary concern really? To reduce your existing alerts? Would it be to balance the operational impact with the risk coverage? Or would it be something more about explaining to a regulator down the line why such thresholds have been set? Okay, so of course, the ideal scenario is to balance both, right? And it's a key target for every regulated institution. You want a balance of the operational impact as well as avoid missing out on any suspicious activity. So that's completely understandable. But what I can see from the answers is that greater focus via your answers is being placed on actually, of course, avoiding suspicious activity and being able to have explainability via your setting of thresholds. So this is quite interesting because some institutions, based on their risk appetite, would be more willing to have higher percentiles, to have lower volumes of alerts, whilst most institutions would prefer to have the risk coverage covered, have explainable thresholds, and at the same time, ideally have efficient thresholds. So this is very interesting, and thank you for the answers. Now, just to recap where we got to this point, we have performed our first step, which is collecting our data, making sure it's clean, making sure it's validated, and making sure it's consistent and has enough historical data to avoid seasonality. We've then simulated our different percentiles over that data set to get monthly alert volumes from P90 all the way to P99.9. And we have initially chosen, as an example, a percentile of P97 as our starting threshold. And now, as our next steps, we want to validate whether P97 is a correct and accurate threshold to move forward with. So the first validation step that is quite easy to implement, but is quite effective in its nature, it's a concept called the need detection validation. And the reason it's called need detection is if we plot visually the graph of the thresholds, of the percentile thresholds on the x-axis of the graph, as you can see here, and the alert volume on the y-axis, where the curve creates sort of a kink, as you can see on the graph here, this is usually a recommended point to set an initial threshold. And this is because this showcases a balance between reducing the operational burden, but still capturing meaningful activity. So this ties back to the most popular answer from the previous slide, actually, which is where most people answered that they want both a risk coverage and a good balance of the false positive alerts. So the need detection curve captures the concept, if you remember, of diminishing returns, because a point beyond P97 starts having diminishing returns, and this is indicated by the curve starting to flat out, right? And when that happens, it means there is less of a positive operational impact as you increase the threshold. Okay. Any point before P97, where the curve is quite steep and facing downwards, indicates there's quite big improvements operationally that can be made by increasing the percentile. So right at the king is usually the perfect sweet spot to kind of set the threshold. Even though we're using this example on the screen, and it's quite, I would say it's probably a bit unrealistic that you set your initial threshold at P97 and then the king is exactly at P97. This is just an example to show how you can validate thresholds. So in the real world, you might have set your initial percentile at P97, but found out that the king is somewhere around P95. A natural step after that is to just set your threshold in between these two, your starting point and your validation step point, which is P96. So if we just consider that P97 as a validation step now is the right one, in this example, P97, if you remember from the previous slide, is a threshold of 14.2K. Okay, and we've taken this first step to validate P97. Now there's a second step that further solidifies this. This is using segments. Okay, so this is where we can avoid a common mistake. So we have picked a percentile, we have validated through the knee curve, but reducing alerts is obviously not enough. We also need to ensure we haven't biased the detection, and we validate that across different customer segments. In this example, we use an independent parameter from the one used to optimize in the threshold itself. So our scenario is one that uses an amount parameter. So naturally, we can create segments using the volume parameter, so the number of transactions that customers transact with every month. If we assume that we construct 3 separate segments for volume, a low, a medium, and a high segment, and then we distribute our customers that have alerted beyond P97, if you remember, into each segment, we'll then get a distribution across these 3 distinct segments. And from our example, we can see that we have sort of an even distribution among the 3 segments. So we have 28% in the low segment, 41 in the medium, and 31 in the high segment. So this passes our check of not having a single segment have more than 70% of the alerting population in it. This indicates that we're not biasing our threshold towards a specific segment, a specific independent segment from our optimization parameter. And this is quite key here because you want to avoid, for example, only capturing suspicious behavior based on an amount parameter, but only from the customer segment that has a high volume of transactions. This might indicate that you're missing potential illegal activity in the low volume segment, which is quite common as well. Just taking a pause here, we have gone through these steps now where pre-deployment, so before you deploy a scenario into a live environment, you can run this analysis, determine appropriate thresholds based on the data and based on the analysis that we use, and deploy such thresholds on a live environment. The point after this is where you allow the rule to run for 6 to 12 months. And then what you have is something even more powerful. And that's you have labeled data or data where the alerts have been worked by your team and the outcomes of such alerts are now available to you. And this is where this next part of the webinar comes in, which is how we can utilize this labeled data, is what we call them, to further optimize our thresholds down the line. Before we jump onto that, do you currently use labeled alert data once you have allowed the scenario or the rule to run for some time to refine your initial thresholds? Okay, very interesting. So the top answer is occasionally, so quite natural, but interesting to see that a lot of people or a large percentage of people on the call have answered not at all. And It's quite key here because, as I said, following the pre-deployment steps that we have just covered is kind of step one into achieving optimized thresholds. A more powerful kind of process, though, is using what we're going to see just now, the labeled data or the alert investigation data that you produce from your different activities and investigations. So it's interesting to see that a large percentage of the answers on the call don't really use that. And this is exactly the point of the webinar, right? Is to provide you with a framework that you can implement to achieve that. So thanks for the answer. Let's move now to post deployment calibration. And again, just to preface this, this is calibration that is happening usually after some time where you have deployed your scenarios or your rules in a live environment, and you have allowed them to run for some time. You have allowed the rule to produce alerts, and those alerts have been worked by your team, and the outcomes of them are stored in your database. What is a very common practice for this type of analysis is what we call above the line and below the line analysis. What above the line, as the name suggests, looks at alerts above the threshold, above your current threshold. So it's looking at alerts that you're currently detecting, okay? And below the line looks at activity below your current threshold. So what you might be missing. And the focus for today would be mostly on above the line analysis, but we'll touch upon below the line as well, just to make sure that the concepts of these two analyses are made clear. Using this type of analysis creates a feedback loop, and it allows us to refine the thresholds even further from the initial pre-calibration phase. So I'm just going to change screens here and put an interactive graph on screen for you. Okay, hopefully this is visible. This might look quite intimidating at first, but it's quite simple really. Let me just clear this up a little bit. So this is what we call a scatter plot, and it's incredibly useful when you're visualizing and viewing, as we said, labeled data. Just to begin with the dotted lines, this blue line in the middle is our current threshold, okay, which is, for the sake of this example, is set at 100. So imagine the amount threshold that you have calculated from the first step, from the pre-deployment analysis, you determine it to be 100. You've allowed this rule to run for some time, and now you have this core data set to label. We have mapped out an ATL of 5% and an ATL of 10%. So increasing the threshold from 100 to 105 and from 100 to 110. And then we have the BTL line right here, which is reducing the threshold by 10%. Okay, so this is just to visually indicate where the different thresholds sit. And now I'm going to begin labeling the alerts that we have. Okay, so you can imagine that you might have different escalation levels. So an alert can go through L1, L2, L3, and eventually become a SAR. You might just have just one escalation level, which is the SAR. But if I just focus on just the false positives for a second, if I see my current threshold and I assume that I increase the threshold to 105, what we see visually is the number of false positives that I'm going to stop producing, right? So any dot, any gray dot between the current threshold line and the ATL 5% line in this example will not be produced as an alert, and thus you can assume will not be a false positive if it was produced in a live environment. The same concept applies when we move all the way to 10%. Everything in between the current threshold and the ATL 10% threshold would not have been captured, should that have been the case. Okay, so obviously from a false positives perspective, it would make sense to, of course, set the threshold to ATL 10%, so we stop producing this large number of false positives in between the two lines. However, if we remember, we want both operational efficiency, but risk coverage as well. And this is how the labeling of the SAR data comes into play as well. Okay, so as we can see here, if I was to set my new threshold at ATL 10%, I would have missed 5 key SARs that have been raised here. Okay, so this is quite concerning, right? From a risk perspective, we absolutely do not want to miss any SARs that have been produced. And this is indicative that should that threshold work being 110, in this example, we would have missed these 5 SARs. So it makes no sense to set the threshold to 10%. However, and for example perspective, we can see that setting the threshold at 5% ATL shows no missing of any SARs, so no missing of risky behavior, was we reduced the number of false positives by this number right here. So in the example, it's about 15 less false positives, right? And then if I bring into the picture the L1s, the L2s, and the L3s, you can see that yes, setting the 5% threshold, you would probably miss 2 L3s, so 2 of the more high risk alerts. But an institution might again take the decision that the risk exposure is not that big, and it makes sense operationally to shift to a 5% ATL. And this graph validates that thinking, validates that rationale, which is the key here, really, because if you run such an analysis post-deployment and you determine that the best course of action and to achieve a more optimized threshold performance is to set ATL 5%, you then have rationale and backed analysis that justifies why you chose that point. You're not missing any SARs. You're reducing the alert burden on your team by reducing all this number of alerts that have not been turned into SARs in between your current and your ATL threshold. So you're achieving both of your goals through this optimization analysis. The BTL analysis is usually conducted when you have concerns that with your existing thresholds, you're not capturing the right risk coverage that you want. Okay, and this would be quite obvious, right? If you would see a lot of SARs or a lot of L3 cases very close to your current threshold line. If that was the case, that would be a cause for concern that maybe shifting your threshold into a low one might have captured even more of that risky activity. The way that we perform BTL is a bit more complicated because, of course, with BTL, you don't have labeled data, right? Because you wouldn't have produced an alert anyway, because this threshold is below your existing threshold line. So the way that you conduct this, if you want to, is that you gather your historical data, right? You gather data from the past 6 or 12 months, and you re-simulate your scenario, but you put the threshold of that scenario to be at BTL 10%. This will give you this extra number of alerts. So all of the alerts that have been produced below your current threshold. And then you would have to get your compliance team or your analysis team to analyze these new alerts from the lower threshold as if they were analyzing actual alerts and label this data with the decisions that they would use to label actual data. So once they do that, you would again have the full picture of what kind of risk level those new alerts would have been, have you had set your threshold to BTL 10%. And then you would be able to see, for example, if you have missed any SARs from the simulation population that you've performed. And if that was the case, you would, of course, take a decision to lower your threshold to a lower level to make sure you capture that illegal activity. But as I said, the most common pattern that we see is that naturally, as compliance officers, we are quite risk averse. So to begin with, I would imagine a lot of you would have set a more conservative threshold, maybe a P95 or a P97. And if that was the case, the room for improvement would have been using the ATL analysis to achieve more efficient operational outcomes. Just to recap everything that we have covered today from start to finish, we have covered 2 key concepts and 2 key pillars: pre-deployment threshold optimization or pre-deployment threshold setting, and then post-deployment threshold optimization. The way that we have achieved our pre-deployment analysis is that we have gathered our data set, we have validated that the data set is consistent and accurate, we have simulated our percentiles that we calculated, reached alert volumes per month, And then we run a two-step process to validate those thresholds using our need detection curve and our segmentation analysis. And then we showcased how we can optimize and analyze post-deployment scenario thresholds. And that is most of the time in the industry performed by the ATL and BTL analysis. Now, of course, we have presented everything in a visual way to make sure that the understanding is there. But in an actual real world scenario, this would be implemented in a backend environment. The simulation would take place via different code sets, and the different results would be given in more number format, if you will. But utilizing visuals is actually recommended, and it's actually good for explainability and auditability by the regulators. So the material that we make available after the webinar will allow you to produce very similar visuals and run very similar analysis to the ones that we covered today. I can see one question from Peter. Isn't the problem with an approach like this that only spots abnormal activity, i.e. if the fraud, money laundering is consistent in one set of these alarms? If I understand the question correctly, Peter, is using this approach, are you saying that there's potentially going to be illegal activity in the lower percentiles, and that would not be captured using a process like this? So we have to remember that the first pillar that we looked at is setting pre-deployment thresholds. So that's a point where you don't have any labeled data, right? And you have to utilize your existing transaction data set to determine where that potentially illegal activity lies. The most efficient way, in my opinion, to achieve that is, like we showed, via the percentile approach and by distributing the customer base and then picking a relatively conservative percentile of P95. That approach might very well lead to some risk coverage not being covered. But the point of the post-deployment analysis that we showcased is where you'll be able to start spotting any kind of behavior not being captured. And if that was the case, and for example, you've allowed your rules to run for some time and you run the analysis, it will become quite clear once you went to perform an ATL or BTL analysis, right? And that's the point where you're able to realistically adjust the thresholds. Any point before that would probably be a bit more unrealistic to say that we're able to capture 100% of the illegal activity, right? Because of the data that we have available to us. The other thing is that the example that we used as a scenario in today's webinar is a very simplistic one, right? It just contains a amount parameter. But in the real world, we'll probably have scenarios a bit more complex than this. And within those scenarios, you might well have, for example, the risk level of the client from the risk assessment stage. And a scenario like this might have been if the risk assessment level of the client is high and the amount produced is this much, then produce an alert. And in that case, you would simulate a customer population where all the customers are of high risk and all the customers have surpassed that amount threshold. So that would be a bit more targeted and will probably give you more accurate results based on the complexity of the scenario itself. There's another question in the Q&A. Will the certificates of attendance and presentation slides be made available? Of course, all the material will be made available, certificates of attendance, and as I said, further material to reproduce this kind of analysis in your more technical perspective. In a more technical perspective would be made available. Question from Thomas. I read that criminals are using AI to normalize fraud behavior, making it harder to detect. Do you have any insight for this? Good question, Thomas. I guess the webinar today was mostly around transaction monitoring. I guess fraud is kind of a different space, and you're right. I mean, AI is being used to evolve the way criminals are conducting their activities. But my kind of feeling is that we as well from the other side can utilize AI to fend off such activity, right? And we have utilized it as a company as well. And I'm sure a lot of other companies have started utilizing AI to detect these abnormal patterns of fraud. It is actually a good pointer to have probably another webinar more focused around the fraud aspect of things. If people want to see that, we're more than happy to cover that. But definitely one of the burning questions of today. What is the best practice in the context of a startup where there is no data set available? Good question. And the only way to approach this is to create dummy data, right? So dummy transactions. And again, with the use of the different LLMs and AI available to us, this is actually quite easy to do. The key thing here is to at least have a sense of the transaction of the predicted transaction volumes and values of your customer base. If you have this core information, you can very easily create a dummy data set of transactions based on kind of your own input to the LLM of what you expect your customer base to transact in terms of the patterns. And then using that dummy data set, you can utilize that in the analysis that we showcased here. So great question, Maria. And it's actually something that we start using with new clients as well from our side, which don't have any existing transactions. The way forward with that is a dummy transaction data set. Another question, would this approach be tweaked in any way for market products like FX, money market activity? Good question. Again, because we're talking about transaction monitoring I think is quite applicable to most industries, right? Including FX. Yes, the rules and scenarios and the risk typologies that these rules cover would differ from industry to industry. Some industries like more complicated scenarios with more parameters, whilst others utilize more simplistic, higher value ones. But regardless of that, this approach should be applicable to all different industries utilizing transaction monitoring scenarios, because the concepts can be applied to all industries really. Is really the percentile approach and the validation steps, and then the post implementation analysis. Another question from Simon. What is the most common mistake that you have made in thresholds fine-tuning? I would say it's the fact that a lot of the time we see companies not really utilizing the data that they have available to them, because the data is sitting there, right? Most companies would have transaction data available, and a lot of them would even have labeled data available after some time of running the different scenarios. So it's just a case of realizing the value that is sitting within your company in your data, and then utilizing that data to optimize your transaction monitoring program. And this is why I wanted to add a key step in the slides in terms of data quality, because yes, a lot of companies might have the data, but it's important that you clean up that data and you make it and you validate it before you start using it in these activities, because the data is going to be deterministic of the final outcomes that you get. So the high quality data that you have, the high quality and more precise the analysis would be that we showcased, and the more precise your detection would be. So I would say the most common mistake is that. And then the second one, which is one of the more common answers that we got earlier on, is some compliance professionals just using previous experience to guide them on setting the thresholds, and again, not really using the data available to them. We have another question in the chat now in the Q&A from Simeon. Simeon says it's a risk-based approach and trade-off. Measure based on your risk appetite, where the loss of potential true hits goes beyond what you can risk. This could still be caught otherwise, while excessive force could kill efficiency for the true hits when the percentage is really high. Yeah, exactly, Simeon. I mean, it's a balancing act, right? It's about achieving the right balance between risk coverage and operational impact. And as we said, different institutions might have different risk appetites. And so the risk coverage would be determined by that. Based on the volumes of alerts produced in an institution, there might be a bigger need to have optimized operational performance. So those measures would be taken to achieve that. So it's really when we run activities such as this, we usually like to recommend different thresholds. So three different types of thresholds: a recommended threshold, a conservative threshold, and then an aggressive one. And again, this can be set using the different percentiles, right? So the recommended might be a P97, a conservative one might be a P90 or P95, and a more aggressive one a P99. So that can be kind of explainable as well from that aspect. Can we have a course for rule writing for TM? A very good question, Emikai. It will probably be a completely separate topic, but definitely one that we can cover. Rule writing for TM usually requires extensive risk assessments from the company beforehand to identify what your key exposures are, then identifying your customer base, and then creating transaction monitoring rules around those key topics. But again, along with the other suggestions that we had today, with the fraud suggestion and a few other materials that we plan to release in the coming months, is definitely a topic that we are going to cover. So thanks for that. I think we covered all the questions, both in the chat and the Q&A, and we're just on time. Hopefully the structure and ideas behind threshold optimization are a bit more clear. As I said, keep an eye out for some exciting material for everybody that joined this call. I'm going to be sharing that with you after the call. Good luck to everyone, and thanks for joining.